Okay, so up to this point we recall. So up to this we discuss about the basics of power converter. That is, the power converter is a converter which converts one form of power into the another form of power, in which we need a electrical energy source. Then we need a power electronic circuit. Okay, so control circuit is also required to control the power electronic devices. The devices used are the SCR, triac, IGBT, etc. MOSFET is also used. Okay, then the classification of the converter. So according to the power conversion, we can classify into AC to DC converter, DC to DC converter, DC to AC converter, and AC to AC converter. So AC to DC converter, that means the converter which converts AC source into the DC source, in which we require the AC source, transformer, rectifier, that is whether it is a control rectifier or normal rectifier, that is then filter is required. If control rectifier is used, then the control block is required. The basic application, that is the mobile charger. Okay, so the applications is the used in the television, computer, cell phone charger, another electronic devices, medical, military and telecommunication equipments also used, mixture and grinder, that is the kitchen appliances, industry machines, commercial products. Okay, so classification, that is control rectifier, under control rectifier, single phase, three phase, six phase, half wave, full wave, center tapped full wave rectifier. Then DC to DC, DC to DC, that means the input is DC and output is DC. It is of two types, step up type and step down type. It is also well known as a chopper. Step up chopper, that means output voltage is higher than the input voltage. Step down chopper, that is the output voltage is lesser than the input voltage. So it is also known as the DC transformer. Classification is the step up chopper, step down chopper. According to the output voltage and current, it is classified into class A, class B, class C, class D, and class E chopper. Then DC to AC converter. Okay, so input is DC and output is AC. It is also known as the inverter. So device is used at a IGBT, MOSFET, SCR, high power rating SCRs are used. Mainly the output voltage is adjusted by the on off device, by making the devices on off, that is the switching, by switching the devices. Classification based on output, commutation, connection, phases, and the source. This is the application that it is used in various applications of the converter. Then AC to AC converter. So AC to AC converter, that is we are getting the output voltage. We are getting the output voltage of desired frequency and magnitude. Okay, this is the classification: cyclo converter, matrix converter, AC voltage controller. Then step up cyclo converter, step down, center tap type, bridge type, single phase to single phase to three phase to three phase, and type cyclo converter. Okay, this is the application of DC to DC converter, or we can say simple application of chopper. Okay, so we can control the speed of the motor by inserting the resistance. Okay, so by here this is the thyristor is used. Okay, so in this circuit what happens, we have to insert here this R1 and R2 resistance are there. Okay, so we have to insert this R1 and R2 resistance according by switching this SCR or by switching this thyristor. Okay, so we are not talking about the operation of this, we are just talking about this operation, because we are making the SR1 and R2. How can we inserting, or how can we change the value of resistance that is inserted in the rotor circuit? Okay, so suppose we assume that this SCR is not triggered. Okay, so when this SCR is not triggered, or we can say that is the turn off time period. So when SCR is not triggered at that time, we assume that it is a turn off time period or T off time period. So during this turn off time period, we are not making or we are not triggering this thyristor. Okay, so at that time this R1 and R2 resistance, these two resistances are there. This R1 and R2 resistances are connected in series. Okay, when this thyristor is not triggered, so it is not triggered, that means this, from this terminal to this terminal, it becomes open circuited. Okay, so there is no role of this thyristor in this circuit because it becomes open circuited. Okay, so at that time when we are not triggering this thyristor during T off time period, these two resistances R1 and R2 are connected in series. Okay, so the total resistance becomes R1 plus R2. Okay, now what we are doing, now we are making this thyristor on the chopper on. Okay, so when we are making this thyristor or SCR on, at that time what happens, it will make this R2 resistance short circuited because this R2 is connected in parallel with this thyristor. Okay, so as this R2 is connected in parallel with this thyristor, what happens, as we trigger this thyristor, it will become a closed path, and this closed path is connected across this R2 resistance. So it will make the short circuit of this R2 resistance. Okay, so the resistance remains in the circuit is only R1. So during T on time period, we are triggering this chopper or the SCR, so it will make the R2 short circuited. So there is only resistance remain in the circuit is the R1 resistance. Okay, so now we assume the T on time period and T off time period. So when we are combining this T on time period and T off time period, so during T on time period we have only R1 resistance. During T off time period we have a R1 plus R2 resistance. Okay, so if we combining these two time period, then the effective resistance, combining these two time period, that means we are switching this SCR, we are making on off, so it is a switching of SCR. So the effective resistance is R is equal to R1 into T on. So during T on time period, we have only R1 resistance in the circuit. During T on time period, that HCR becomes on. Okay, so there is only R1 resistance. So we can write that R1 into T on plus T off time period. That means when this SCR is off, this SCR is off at that time, this is the series connection R1 and R2, so the resistance becomes R1 plus R2. So during T off time period, the resistance is R1 plus R2. So we can write R1 plus R2 into T off whole divided by T on plus T off, that is the total time period T. T on plus T off is the total time period. So this is the effective resistance R in the circuit during the total time period T. So according to that, we can insert the resistance in the rotor circuit, and according to that, the speed of the motor is controlled. So by using this chopper circuit, we can control the speed of induction motor. Okay, now another application of AC voltage controller. Okay, so here we can control the speed of induction motor using AC voltage controller. Okay, so in AC voltage controller, here also SCRs are used. So these two SCR S1 and S2 are connected anti-parallel, S3 and S4 are also connected in anti-parallel, and S5 and S6 are also connected in anti-parallel. Okay, so the speed of induction motor is changed by changing the stator voltage. Okay, one another method to control the speed by changing the stator voltage. As we change or as we adjust the stator voltage, the speed of induction motor can also be changed or adjusted. Okay, so in each line we have a 2 SCR, S1 and S2, S3 and S4 and S5 and S6. All these 2 SCRs in the line are connected in anti-parallel. Okay, so when S1, S3 and S5 are turned on or are triggered, at that time current will flow in this direction. Okay, and when S2, S4 and S6 are turned on or triggered, at that time the direction of current is like this. So the opposite direction of current will flow. Now how can we adjust the angle, how can we adjust the stator voltage, or how can we increase or decrease the stator voltage? Okay, so by triggering or by switching this SCR, we can control or adjust the speed. Now how can we adjust the voltage? So by changing the firing angle of SCR, voltage applied to the stator will change, and according to its speed will change. Okay, so whatever, if the firing angle is less, the output voltage from this converter is more, and if we increase the firing angle, so whatever output voltage we are getting is less. So by controlling the firing angle or by adjusting the firing angle, we can control the output voltage from the of the controller, and this changed output voltage is given to the stator of the motor. So as the voltage given to the stator of the motor is changed, the speed of motor will also change. So this is the another method to speed control of induction motor using AC voltage controller. AC voltage controller, that means input voltage is AC, output voltage is also AC, but we can get the variable or the desired AC output voltage. So as per the requirement of us, we can adjust the output voltage by adjusting the firing angle of SCR. This method is simple, reliable, and wide range of speed control is available by this method of using AC voltage controller. It is also used for small and medium capacity motor. So for small and medium capacity motor, we can easily control the speed of induction motor using this AC voltage controller. Now next, the speed control of induction motor using cycloconverter. Okay, so cycloconverter, so if we see that it consists of the 6 group of converter circuit. 3 groups are as positive while another are the negative converter. Okay, so this SCRs for positive converter, these SCRs for negative converter. Likewise, this is first, second and third. So in all we have this positive converter, this is the negative converter, positive converter and a negative converter. Okay, so see, it consists of 6 group of converter circuit, 3 groups for positive and 3 groups of negative. So these are the 3 groups, 1, 2 and 3 for positive. This is 1, 2 and 3 for negative. During each positive half cycle, the positive group carries the current, and during negative half cycle, negative group carries the current, and the duration of conduction of each group of thyristor determines the output frequency. As per the conduction of the positive group of thyristor as well as the negative group of thyristor, the output frequency will get changed. So we can change the output frequency by changing or by switching of the positive group of SCR as well as the negative group of SCR. Okay, so by using this cycloconverter, we can control the speed of 3-phase induction motor also. So it is a 3-phase cycloconverter. This converter is the 3-phase. Yes.
ബാലകനെന്നില്ലേ 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 അവർക്ക് സ്വാതന്ത്ര്യമില്ല. മറ്റു മതങ്ങളിൽ ജനിച്ചതുകൊണ്ട് സഞ്ചാര സ്വാതന്ത്ര്യം നഷ്ടപ്പെട്ടോ? തന്റെ മതങ്ങളിൽ തുടരാനുള്ള അവകാശവും ഇല്ലാതായോ? ഇഷ്ടമില്ലാഞ്ഞിട്ടും വിവാഹിതയാകാൻ നിർബന്ധിക്കപ്പെടുകയാണോ? നീതിക്ക് വേണ്ടി പീഠത്തിൽ പൊരുതിയിട്ടും വീണിട്ടും സ്വതന്ത്രയാകുവാനുള്ള നീതി ലംഘിക്കപ്പെട്ടോ? ഏത് ഭരണഘടനയാണിത്? ഏത് മതപുസ്തകമാണ്? മതചരടുകൾ കാഴ്ചയും നന്മയും മറയ്ക്കുന്നതെന്തിനെന്ന്?
കുറച്ചുകൂടി വായിക്കുമ്പോ ഒരു ഇതില്ലേ? വിവാഹം കഴിക്കാൻ പറയുന്നത് എന്തിനാ? അതൊക്കെ ഒന്നൊന്നും മാറ്റും.
Okay, sir. So I will conclude it, sir.
Okay, and participants audio ચાલુ છે તો તમે તમારા ત્યાંથી એને મ્યુટ કરી શકો છો. You can mute it.
Okay, so let me stop here. So today we discussed about the power electronic converter. So we have a power electronic converters. So we discuss about the basics of the power electronic converter. What is the power electronic converter? What is the function of the power electronic converter? Different types of power electronic converter, that is the based of the power conversion. We have a AC to AC, AC to DC, DC to AC, and DC to DC converter. According to that, we have a different applications of this converter. So we discuss AC to DC converter, DC to DC converter, DC to AC, and AC to DC converter. We also discussed different applications of chopper, cyclo converter, AC voltage controller. Okay, so let me stop here, sir. Thank you very much, VK Patel sir, Head of the Department Electrical Engineering, NG Patel Polytechnic, for inviting me to give a lecture on the power electronic converter topics, and also thankful to the principal and management of NG Patel Polytechnic Isloli. Thank you, sir.
മറ്റു മതം വേറെ മതമൊന്നും വേണ്ട, ഒറ്റ മതത്തിനല്ല, എല്ലാത്തിനും കൂടി പറയണം.
મને હોસ્ટ બનાવી દો.
Okay, sir.